In this video, I'm going to show you how to apply the sum and difference identities to simplify trigonometric functions wherein the angle is not a special angle. An angle is not a special angle if it's not 30, 45, 60, or even 90, 180, 270, and 360 degrees. They are special because you can get the trigonometric functions of these angles directly. As compared to what we have here, we want to find the sine of negative 15. 15 is not a special angle. Cosine 75 is not a special angle. Later on, we'll be simplifying a tangent function also. So how do we simplify sine of negative 15? The key is to use the special angles or the combination of the special angles to get a negative 15. So how are we going to do that? For instance, I can use 30 and 45 to get negative 15. That is when I subtract 30 and 45. So 30 minus 45 is negative 15. Hence, these two expressions are the same. Once you do that, you should be able to see that this is like a sine A minus B. And from the set of identities that we have, sine A minus B is equivalent to sine A cosine B minus cosine A sine B. In this one, A is 30 and B is 45. So using the identity, we have sine of 30 cosine of 45 minus cosine of 30 and sine of 45. The good thing about this is that all the angles now are special angles. Therefore, you can get each value using the special triangles. But what are the special triangles? So you set, okay, if you're not familiar with the, or if you do not know what is the sine of 30 directly, you can always create your 30, 60, 90 triangle. And if the side opposite 30 is 1, by some computations, when you compute for the other side, the opposite side, the adjacent side rather, is a square root of 3, and the hypotenuse is equal to 2. Okay, so this video will not show you how this were derived, but since we will be applying it, you need to know that the sine in a triangle 30, 60, 90, the side opposite is 1, the side of 60, or the side opposite 60 is square root of 3, and the hypotenuse is equal to 2. Okay, the other triangle that you need to know is the 45, 45, 90 triangle. In a 45, 45, 90 triangle, take note that the two angles are the same. Therefore, if the two angles are the same, then the sides opposite these angles are also the same. So let's say if I make this side square root of 2, and the other side must be equal to square root of 2. And it will be very easy to find the hypotenuse, because all you have to do is to apply the Pythagorean Theorem, and when you do that, you get the hypotenuse equal to 2. Okay, so again, I will not be showing you how. You can do that on your own. Use the Pythagorean Theorem to arrive at the hypotenuse 2. Okay, knowing these two triangles, you can find the sine 30, cosine 45, cosine 30, and sine 45 easily. For example, if I have to find sine 30, all I have to do is to get the opposite. Remember from the SOHCAHTOA, if I'm looking for sine of an angle, I can use this triangle or this triangle depending on the angle by SOHCAHTOA. So sine means opposite side, so opposite side over the hypotenuse. So sine of 30, so with respect to 30, this is the opposite side. So that's 1. And the hypotenuse, which is equal to 2. Cosine 45, since the angle is 45, so I'll go to the triangle with 45, 45, 90 angles. I get one of the 45 angles. So cosine means adjacent hypotenuse. It's the side near the angle, square root of 2 over the hypotenuse 2. Then minus cosine 30. So similarly, we get adjacent of the angle 30, so that's square root of 3, and over the hypotenuse 2. And finally, sine 45 is opposite of the angle and then hypotenuse 2, so square root of 2 over 2. And then just simplify this. This is a product of fractions. When you multiply fractions, you multiply the numerator over the product of the denominator. So 1 times square root of 2 is square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2 is square root of 6. If you are not familiar with multiplying of radicals anymore, or if you cannot remember how to multiply radicals, the rule is you multiply the numbers inside the radical sign and then put the number inside the single radical sign. So as you can see, 3 times 2 is equal to 6, and 6 is inside the radical sign. And then 2 times 2, this is equal to 4. For addition or subtraction of radicals, you can only combine radicals with the same numbers inside. Okay, we call those similar radicals, but they're not similar. Square root of 6 cannot be, you cannot even express square root of 6 as square root of 2. There are other radicals that can be simplified into the square root of 2. Okay, so all we can do here is combine this in this way. So the same denominator, so that's 4, and then you write square root of 2 minus square root of 6. This is the value of sine negative 15. Okay, so you will not be asked to simplify this in decimal form. So once you reach this expression or number, you can already stop the solution. Okay, so recap. The idea is find two special angles. When you subtract or when you add them, it will give you the angle in the function. So the perfect combination for this is 30 minus 45. And after that, you have to apply the corresponding formula. Since you're subtracting two angles, then you have to use the difference of two angles. Okay, and then apply. So sin cos sin, or sine A cosine B, cos A and sine B. Okay, and then just use the two triangles to get the numbers for each function. So knowing this, it will be easier now to find the cosine 75 because you are familiar with the idea. So 75, if I ask you what are the combinations or what two angles, when you add or subtract them, it will give you 75. For sure you will say, oh, I can have 30 and 45. So this is of the form cosine A plus B. But what is the identity for cosine A plus B? The identity for cosine A plus B is cosine A, cosine B minus, okay, for cosine you can remember it as opposite sign. So if this is plus, we use minus, and then sine A, sine B. So applying this formula or identity, we have cos of 30, cos of 45 minus sine of 30, sine of 45. The good thing about this is we already know what is cosine 30, cosine 45, sine 30, and sine 45 from the previous problem. Cosine 30, we found that to be square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 30 is 1/2. And sine of 45 is also square root of 2 over 2. And then simplifying this, same idea. This is square root of 6 over 4. This is square root of 2 over 4. Combining the two fractions, you have 4. as a denominator and square root of 6 minus square root of 2. So that's the value of cosine 75. Now we go to the last item in this set. The last one is to find tangent 105. What is tangent 105? So same idea, we look for a combination of two angles whose sum or difference is 105. So I can use 45 plus 60 or 60 plus 45. The order doesn't matter. If you want to use 60 and then plus 45, there's no problem with that. Now, so this is in the form of tangent A plus B. The formula for tangent A plus B, or the identity for tangent A plus B, is tangent A plus tangent B all over 1 minus tangent A tangent B. You need to know the formulas, otherwise you will not be able to solve this, because this is the key. These are the key in solving each problem. So applying the formula, this is your A and this is your B. So we first get tangent of 45, add that to tangent of 60, then divide it by 1 minus the tangent of 45 being multiplied to the tangent of 60. Okay, and again we look for the values of tangent 45 and tangent 60. So I'll use this space. So this will be equal to tangent of 45 SOHCAHTOA, that's opposite over the adjacent. So if you look at 45 degree angle, the opposite is square root of 2, and then the adjacent is square root of 2, which is just equal to 1, plus the tangent of 60. So we look at 60, the opposite is square root of 3, and the adjacent is 1. And then we have 1 minus, okay, square root of 2 over 2, that's tangent of 45, square root of 2 over the square root of 2, being multiplied to the tangent of 60, which is square root of 3 over 1. When you simplify this, so square root of 2 over square root of 2 is 1, plus square root of 3 over 1 is square root of 3. Denominator is 1 minus square root of 2 over 2, again that's 1. So 1 times square root of 3 over 1, this will give you square root of 3. Okay, so just to rewrite the final answer, this is 1 plus square root of 3 over 1 minus square root of 3. That's the value. You can further simplify this expression, but our main focus here is for you to know how to apply the formula and for you to know how to get the specific number or the specific value for each function. So once you reach 1 plus square root of 3 over 1 minus square root of 3, you can already stop there, unless you are being asked to find the value in its simplest form. Okay, so these are the 3 examples on how you can apply the sum and difference formulas. Take note that there will be problems in which you have to do sine A plus B, you have to do cosine A minus B, or tangent A minus B. So not all identities were used here, but the idea will be the same. So it is crucial in the solution that the student knows the different identities for the sum and difference. Otherwise, you will have difficulty finding this, or I don't think you can find another way in finding this aside from using your calculator, of course. But these problems will not allow you to use a calculator, so this should be the solution that you should do. Okay, so that's it. So I hope you learned something from this video and you can apply the ideas when you solve similar problems or problems similar to this. That's it.